Hi, we left off with Rutherford's model. And again, Rutherford had that positive dense nucleus that was very tiny and a lot of empty space with electrons whizzing around. But scientists like Bohr thought, well, if the nucleus is positive in the center and the electrons are negative spinning around, well, they're opposites. They should attract each other. But we know they don't. Why? So he ends up also studying the atom. And he studies this phenomenon called atomic spectra. Right? It was known at that time that, white light gives off the whole rainbow: red, orange, yellow, green, blue, indigo, violet. But elements did not give off that whole spectrum. They have specific lines of color, specific lines of light with different energies. And every element was unique. No two elements had the same sort of fingerprint, the same barcode. So, what's going on there? What causes this uniqueness? And Bohr was thinking, let's look at the electrons. So we're going to take a look at a little video. And I want you to imagine these energy levels as circles, right? We're showing just the part of it, right? So down here would be the nucleus, and this would be part of a larger circle, rings. Here we go. Okay, so we have the ground state, which is closest to the nucleus, and then rings outside that are the excited states. Electrons start off in the ground state, and then they can absorb energy, like a photon of energy. And once that energy is absorbed, they're no longer able to fit in that level. They have too much energy. So they jump up to an excited state. And when they do that, they're unstable. The excited state, very unstable. So eventually, they go back down to a lower level. And when they go back down to that lower level, they release that extra energy that they had absorbed. And they release it as light. Okay? And that's how you get those lines of light. Well, why is every element unique and special? Well, they have a different electron configuration, different arrangement of electrons. Okay. So they're going to show one more time with a different energy. Again, the electrons start off in the ground state. They absorb energy, this time absorbing more energy. So it's going to go to a higher excited state. Right? Remember, energy levels, so that's how we imagined it. And that excited state is unstable. That electron won't stay there and will, again, jump back down and release that extra energy in the form of light. And since it was more energy, it'll be a different color light, in this case, violet. And that's how those lines of color, the atomic spectra, are made. Right? Every element is unique because it has a unique set of electrons in their energy levels. This was his idea. So every element gives off a unique atomic spectrum, a colorful barcode, kind of like a fingerprint. Right? So he imagined that electrons aren't just whizzing around everywhere in that empty space of Rutherford's model, but electrons in his mind are arranged in orbits around the nucleus, and every orbit has a different energy level. And his evidence are these atomic spectra. He can explain that phenomenon. And this leads to his solar system or planetary model, where he imagines that electrons are arranged in circles around the nucleus, and each circle has a different energy level. And it's sort of like, if you think about it, planets orbiting the sun, right? So in his model, that nucleus is kind of like the sun, and the electrons are kind of like planets orbiting it. And it looks something like this, right? There's that nucleus and the electrons orbiting it in these fixed, predictable layers, or so he thought.